All right, we're going to talk about some function examples and talk about if they are injective and or surjective. So our first function here, we have h from the naturals to the naturals given by h of n equals n squared. And the first thing we're asked is to determine if it is injective. Okay, so remember, injective means that every element from the codomain is the image of at most one element of the domain. Okay, so one thing that we could do here is just think about what are some elements in the codomain, and let's think about what elements from the domain they might be the image of. So for instance, since our codomain is the natural numbers, we can start with 0, right, because that's the first natural number. And of course that we know that h of 0 would be 0 squared, which equals 0. So in other words, the input value of 0 gives us the output value of 0, and that's the only natural number that when you square it, you're going to get 0, right? All right, so then let's look at 1 next. Well, what natural number, when you square it, do you get 1? Or in other words, n squared equals 1, then what is n? All right, so if you're thinking kind of in terms of traditional math here, you're probably thinking, well, there's two answers. There's 1 and there's -1. But we have to be a little bit careful here because any answers have to come from the domain, which in this case is only natural numbers. -1 is not a natural number, so we get only the solution n equals 1 here. So again, the output value of 1 is the image of the input value 1. All right, let's go on to the next natural number. Is that the image of anything? Or in other words, is n squared equal to 2 for any natural numbers? And the answer is no, because if we take the square root of each side, right, we get the square root of 2, but that's not a natural number. Okay, so there's no solutions, right, or no. And in the naturals gives n squared equals 2. All right, so we could keep going. We could see that there would be no solutions for if we choose to n squared equals 3. If n squared equals 4, then we would get that n equals 2. So just kind of looking at these handful of examples is making us think that the function might be injective, because in all of these cases, the output values were the image of at most one element from the domain, right? So 1 was the image of n equals 1, 4 was the image of n equals 2, 0 was the image of n equals 0, and 2 and 3 are not the image of anything, but that's okay. All right, so kind of returning to our question, is it injective, or how do we think about that in kind of the more general case? So if we take an arbitrary element from the codomain, which is the natural numbers, then we kind of have two cases. So I guess we could say, I'm going to call it M. So if M is in the naturals, and again, I'm thinking of this as being the codomain, then we have two cases. Either the square root of M is a natural number, in which case h of the square root of M equals the square root of M squared, or in other words, just M. All right, so in that case, we have the arbitrary element from the codomain, and there's only one element from the domain which gives M as the answer, right? Because negative square root of M would not be a natural number, so we wouldn't want to count that. If the square root of M is not a natural number, then M is not the image, of any element from the domain. Okay, so I guess what I'm trying to say here is we have two cases, right? Either the square root of that number, M, is a natural number, in which case the square root of M is the only one in the domain whose image is M, or M does not have any elements in the domain that get sent. Sorry, M doesn't have any elements in the domain that get sent to it. Or in other words, it's not the output of any numbers from our domain. So from that we can conclude that H is actually surjective. Sorry, that should say injective. I'm jumping ahead of myself trying to think about the next piece already. All right. So yeah, the next question is it surjective? We've kind of already touched on this a little bit because surjective means every element of the codomain, or in other words, every natural number is the image of something from the domain. And that is not the case because, for instance, we can choose a number that's not a perfect square. So for instance, 5. So 5 is in the natural numbers, but there is no n in the naturals such that n squared is equal to 5. All right, so just giving one example of an element of the codomain that doesn't have a corresponding element in the domain is enough to say that it is not surjective. All right, so let's look at the second example here, which is the function w, which is from z, which is the integers, to the naturals, given by w of x equals x squared. And again, we want to know, is it injective and is it surjective? Okay. So you might be thinking that this looks a whole lot like our first example, and it does, but it has a point. So first off, don't be bothered by the fact that I'm using x instead of n. It's just representing the input value. The big difference here is the domain of the function, which here in this example is the integers. In our first example, it was the natural numbers. All right. So first we want to know, is it injective or not? All right. Or in other words, is every element of the codomain the image of at most one element from the domain? And the answer is no, kind of for the reasons that we talked about in number 1. So remember in number 1, I said when we were solving this equation, n squared equals 1, you would traditionally think that that has two answers, which are -1 and +1. But since we were restricted to the domain of the natural numbers, we only had one answer from that. But here, if we choose the output element, I guess we'll use 1 again, and say for what x is x squared equal to 1, then here we do get both of those answers because our domain is the integers, which includes both the positive and the negative. Okay, so since 1 is the image of both +1 and -1, that's enough to say that this function w is not injective. All right, and now for determining if it's surjective, you might be thinking no, for the same reason that number 1 was not surjective, and you would be correct. So we would say w is not surjective because its outputs, right, are only the perfect squares. 5 is a natural number, but there is no integer x such that x squared equals 5.